All right, with this lesson 5, I'd like to go ahead and use our grain diameter measurement code that we did last time to now analyze particles in a matrix. And I'm going to go ahead and do the harder problem of looking at two different types of particles in a matrix. So this is a metal matrix in this case, reinforced with two different types of particles. Okay, and so we'd like to get out information like average size of these different particles, the gray here and the black. I'd like to get out the numbers of them, maybe the area fraction, and maybe their size. So we're going to go ahead and do that. Since this involves two different types of particles, I'm going to have to analyze this image twice, and so things are going to get a bit more complicated. And so to make everything much easier and more compact, we're going to go ahead and write some function definitions for the code that we've been using so far. And so I've got all our import statements that we've used before. I've got this copy statement in here because we're going to make a copy of our image. We can talk about that later. And I want to go ahead and define three main functions. So the first function I've called prep image, and this one is expecting to get a blue, green, red image format, and that's the image format that we get from the image read command from CV. It is a blue, green, red code, and when we show it in matplotlib, it's expecting RGB, red, green, blue code, and so we'll have to convert this. Okay, but it does expect the blue, green, red. Putting that in, this prepping the image is going to undergo a pyramid mean shift filter like we've done before. Helps to kind of even out the color ranges, and it's going to also convert the image to an RGB image. We are going to also convert, once we do the mean pyramid shift, we're going to convert it to a grayscale image, and then we'll apply the Gaussian blur. So these are all the filters that we've done before, and I've just put them now in one nice place. And so we're going to pass the prep images, again, our image to be analyzed and placed in the grayscale. We're going to do the pyramid filter size. So this is like the size of the kernel for it. And then we're going to do the range. This represents the range in color space that it considers the same. And those will go in here. And then we'll also pass the blur size. That goes into our Gaussian filter. And then this function is going to display three different images for us, just so we can see how we did when we run it. The original image, the grayscale image that's been pyramid filtered, and then finally the final blurred image. And then it's going to return 4 arrays of data. It's going to return the RGB version now of our original image that we read in. It's going to return that pyramid shifted filter. It's going to return the grayscale filter, grayscale image, and it's going to return the blurred image. So when I call this, I'm going to need to put 4 different variables out front of it so that I have a place for each of these to go. All right. So as we use these filters, just come back here to see what these values are pointing to. The other one we have is the thresholding. So this is where we're going to take the image from this step, and we're going to then convert it into a black and white image. So this thresholding I called thresh simple, because we're just going to use the simple thresholding. We had 3 different types that we looked at last time. I'm just going to go ahead and use a simple threshold binary, and I'm going to use an inverse in this particular case so that the particles show up white. So I'm going to pass it a grayscale image. That's what it's expecting. I'm going to need to define the min and max values for my threshold. The max for almost everything that we've done and will do is 255. So it's the min I'm going to need to adjust. This is the kernel size that goes into this opening, morphological opening, which is reduces the noise a little bit in our image. and then the number of iterations that this opening filter will undergo. So that's what we're going to be putting in there. So kernel size, this is going to be typically something like 5, and maybe the iterations of 1 or 2. But we can adjust those. It will also plot automatically for us the original image and the final image that's called opening, that has been noise reduced. So it'll plot those so we can see how we've done. And then this returns only one array of data, and that's for the opening image. And then we've got the segment case, and you can see it's got 6 return values. So this is all described here. But we're going to go ahead and put in our original RGB image that we want to segment. Segment meaning we're just going to label, color all of our particles, and we're going to have a table of values for them. We're going to put in our thresholded image that we got out of the last case, the kernel size again, and we're going to do the number of times we want to dilate, and that's going to make our background, and then the number of times we want to erode, which is going to make our foreground. And so here are the commands. Again, these are all pulled out of what we did last time. See, these are all the same commands, just grouping them all together nicely here, and we can control each of them through these variables, the number of iterations, and then the kernel size here that generates the kernel in a morphological cross format. And then we've got our unknown, which is going to be just the subtraction of those two. And then finally what we're going to do is we're going to take our sure foreground, and we're going to go ahead and connect all the components, and that's basically going to label them with markers. And we adjust the markers like we talked about before. We run our watershed program, and we go ahead and call the boundary, which is labeled -1 by the watershed program. We're going to go ahead and call all those pixels red. So this is, again, RGB we're supplying, so full red 255. And then we're going to go ahead and convert all of our numbers that we got in the markers, the labels. We're going to go ahead and convert them to RGB colors. And that's how we're going to generate finally our colored image. Right? And we're going to go ahead and show those as well in the plot so we can see and how we're doing. And then this will return the image again in RGB. It's going to return the background, the foreground, the subtraction of the two. It's going to return our final array of marker data, and it's going to return our colored image. All right, so that's all we have to do, is to go ahead and use these 3 functions now. So let's go ahead and work through that. So we're going to get set up first by reading in our image. So we're going to go ahead and do a CV image read, and we'll read in this metal matrix composite image. And you can see here when I ran this, this has a micron bar in it, and so this piece here is telling it to just go from 0 to 215, and that's going to be right above this micron bar, so we can crop that out. Okay, so you may or may not need this step depending on what image you have, and you have to adjust these according to the number of pixels. So I've already ran this a few times to get this right. Okay, so let's go ahead and, oops, I didn't run all these. Let's go ahead and run this. And there they are. Right, so what I do is the first time I come in here, maybe we've got, I'll just cut off, oops. First time I come in here, I want to include everything. So there it is. All right, this is the pyramid mean shift one, this is the blurred one, but I've got the micron bar in here. And so that's where I would come in, and I just sort of keep adjusting this, maybe 0 to, let's say if we did 250, what I would see is I have no change because that's actually the maximum number I've got. Let's say 30. Now you can see I'm starting to cut off the micron bar. So this is just a little trial and error until you get it to be gone. So you can do that on your image. All right, so we ran through and we prepped our image, and I'm using a pyramid filter kernel size of 5. That's my neighborhood size around each point that I look at. And then I've got my color range scale, and then I've got the size for my blur, my Gaussian blur. Okay. And you can play with these 3 values to see what effect it has on your image. So those are the main 3 that you have to play with. All right, so the next thing we want to do in this particular case, since we've got 2 different color phases, reinforcing phases to analyze, I like to have a way when I do the thresholding to be able to look at just the black regions and just the gray regions. And so what would be good to do is to run a histogram on all of the grayscale values in this picture. So remember, when I take a look at something like my blurred image, right, it has, each pixel has a single value in it from 0 to 255. 0 being black, 255 being white, because this is a grayscale image. Okay. So when I called this prep image, remember we've got 4 outputs to it. So here's my variables for them. Image, the original, that shifted one. I called this one the image gray, and then image blur is this one. So those were my variable names for that function. Okay, so what I like to do is I'm going to go ahead and take all these points by simply flattening my data there. So now I've got one array that has all of my data points in it, all the pixels, but it's now just in a single array. So in that form, I can then just go ahead and apply the histogram to it. Right? So there it is. This histogram is a pandas command, and so I need to convert this NumPy array into my pandas series, since it's not a data frame in this case, because since it's just a 1D array. And then I can go ahead and apply that histogram with 80 bins. So go ahead and we'll run that. And so the thing to see with the histogram is, first, this is black on this end and white on this end. So you can see the kind of the average white color. This is the matrix. You can see the grayscale color that's showing up for all the grayscale particles. And then this is the black particles. You can see the numbers for those. And so this helps me to know where to do my thresholding. My thresholding is going to, when I supply the minimum value, it's going to take everything below it and make it white. And so that's what I want to do now when I go ahead and use my simple thresholding command. I'm going to send it my blurred image, and then my maximum is always 255, but my minimum here of 200. So if I come on this image here, this says that everything below this level, 200, that's my gray particles and my black particles, all of those are going to become white. Everything above 200, which is my white matrix, is going to be turned black. Okay. And then I'm going to run another thresholded image, but using 100. So now I'm going to convert everything below here, which is just my black areas, to white. And then I'm going to take my gray and my white background and convert all of those to black. So then if I subtract my 2 thresholded images, I can basically pull just this one out. So let's see how that works. Okay, so this is my simple threshold. And you can take a look at the values of 3 and 1 for the thresholding. Let's just go ahead and do it. So that's the kernel size and the number of iterations on my opening. Okay. So my kernel size here is just 3. I'm going to do a single iteration on my opening. All right, and then we're going to go ahead and show these 2 images. So my threshold it from my blurred 1 and blurred 2 image. And then I'm going to take and subtract those two. So subtract the second from the first. And I'm going to go ahead and show that. All right, so let's see what this looks like in terms of pictures. So here's my grayscale. Okay. My first thresholded image we said was minimum of 200. So 200 said that everything below here would become white. That's my gray regions and my black regions. See, so all my particles, whether it's gray or black, you can see here now is all turned white. And then my background, which is the white, has all been turned black. Okay. So that's that one. My second one was everything below 100. So I'm now skipping the gray, and I'm only doing the black regions to white. And now my gray and white regions will turn black. So here it is. And so now you can see that what I'm highlighting here, white, is just the black regions. So if I was to take this image and subtract off this one, then what I'll be left with are just the gray regions. So this is gray and black, this is black. Subtract them and I get just the gray pieces. And so that's what we've got here. And you can see when in the subtraction process, there is not perfect registry, or the first image is actually has a little bit more in it than the second, and so you do get this outline of the black regions that are showing up. But these white solid regions are all the gray particles. And this will go away when we actually continue with the analysis. So that's how we get to a thresholded image. If you only had one type of particle, then you just obviously don't have to do this twice. Just do it once, and you get your thresholded image. All right, let me stop there, and I'll come back and we will continue on with the analysis of this now that we have the thresholded piece.